My name is Torsten Lempe. I am the head of the distribution network operation here at Stadtwerke Fellbach. I've been with the company since 2000 and worked as a network manager for 22 years. We very quickly realized that the sensors from SMIGHT Grid are very easy to install. So we don't have to do a lot of wiring, and we don't have to disconnect anything to install the sensors. The connection with the gateways works perfectly via an app. And the SMIGHT Grid user interface is so simple that we have achieved a very high level of acceptance in our company because it is relatively simple and clear. We have a total of 156 secondary substations in our network, of which we will have equipped 51 substations by the end of 2023. So we are at around 30%. One major challenge is, of course, the increasing demand for energy caused by the mobility transition and the heating transition. The expansion of rooftop solar systems is a major challenge as well. In addition, there are regulatory requirements that we have to implement, be it the electricity price break or Section 14A of the ENWG. The Metering Point Operation Act and tax changes are all things that we have to deal with at relatively short notice, and that tie up a lot of our capacity. SMIGHT helps us a lot with grid management and grid planning. We also use SMIGHT when we disconnect substations for maintenance work to see whether the loads can be handled by other cables. We use SMIGHT for our in-house investment planning. In other words, if we identify grid bottlenecks, we can make budget plans for the coming years. I have now started SMIGHT IQ and can see at a glance what is going on in the grid. We have different colors for the transformer stations here. Green means everything is okay, yellow is within the limit, and red shows that something is potentially problematic. I would therefore first zoom in on the substations marked in red, display the substation data, and get an overview. Here, I have the total current of the substation, the sum of all measured outgoing circuits. And here, I can see the 5 tiles of the measured feeders. You can see here that the Schwabstrasse 17 outgoing feeder is loaded with 86%. And let's take a look at it. We click on it and see the last 30 days. We then have the option of showing the threshold values. And we can now see that we had more threshold violations here in December, that the circuit was heavily loaded. We decided that we didn't want to leave it like this over the holidays and carried out some reconfiguration works. We carried out the switchover on December 18th. And you can clearly see that the load on the circuit has decreased, and we have not had any more violations of the upper threshold since then. Here's an example where we carried out network reinforcement resulting from the findings made in SMIGHT's system in another substation. In the Bubengarten substation, we have the Gartenstrasse 15 feeder. I'll now take a look at the last 365 days, and you can clearly see that we had limit violations here in February. These occurred again in April. In the summer, the load on the circuit decreases, and here in the autumn, you can see how the load increases again. In winter 22-23, we thought about how we could relieve the load on this circuit, and then made plans over the summer to lay 120 meters of new low voltage cable, and thus relieve the load on this circuit. You can clearly see here that we completed the work in December 23rd. And the load on the circuit has been significantly reduced. We have now switched the load to another circuit. We now go to the neighboring substation. The the Neue Straße substation. We display the outgoing circuits here and take a look at the Neue Straße 13 feeder. We select the last 90 days and see that the circuit only has a low load because this was a cable end with only a few connections on it. Then, in December, we transferred the load from the Bubengarten circuit to this circuit. We also use the SMIGHT IQ Cockpit for the troubleshooting of faults. We had a case in Fellbach Oeffingen where a customer called to say that they had a power cut. We knew that we had already equipped this circuit with SMIGHT sensors and then scrolled to this substation in Remserstraße. I am now selecting a user-defined date here. The fault was on February 17, 2022. Then I'll go to February 17. Find the Remserstraße 40 feeder. Set the current values of the individual phases and take out the maximum values. Then we see here that there was no current flow on L2 at around 17:30. This was an indication that a fuse had tripped in this substation. L1 and L3 were still working, but the current flow went to 0 on L2. We were then able to send the technician directly to the Remserstraße substation to check the fuse there, and the fault was rectified very quickly. He didn't have to go to the house connection or check the cable distribution cabinets first. Instead, he was directed straight to the substation where the problem was. With the SMIGHT IQ Cockpit, we can also see feed-ins, e.g. from solar systems. We have an example in Lise-Meitner Straße. Many house connections are connected to this substation, which are used for feed-in. For example, in Otto Hahnster 8. Let's take a look at the last 365 days and see that we have reached the upper threshold limit, especially in early summer. So we don't yet have a fuse rating violation, but we are still at the upper threshold and can see that a lot of current is flowing here. Let's zoom in a bit, and we can see that the upper threshold value is only briefly exceeded. The customer has a solar system with $140 kW on the roof and has asked us whether he can feed into the grid. The house connection was designed for this, and we now have the option of using the SMIGHT IQ Cockpit to check whether the fuse rating is being maintained and whether there is an overload on the equipment. Not in this case. If the customer were to install more solar panels modules now, we would have to react because we can see in the SMIGHT IQ Cockpit here that we don't have much headroom left up to the fuse rating. On 11/09/2023, we received an email with a warning message that there was a fuse threshold violation on the Ring Road substation. I now go there and see here that we have exceeded the fuse rating here once. I now have the option of zooming in here. I can go down to the minute. So here we have 17:43, 44, 45-minute values, and this event was within 1 minute. As it has only occurred once in the last few months, We have it on our radar, but we won't be following it up with any further action, as it was a one-off event. Here too, the SMIGHT IQ Cockpit helps us to receive a report and then assess whether we need to take action or just observe. The low-voltage grid is doing well. Of course, we only know the exact figures for around 30% of the grid that we have equipped with SMIGHT technology so far. That's where we get the exact values. Of course, there are circuits that have a higher load and those with lower loads. We can only discover this with the use of SMIGHT technology, and we want to look even further into our low-voltage grid in the future. Our aim is to equip 60% of the substations in our network with SMIGHT technology.